Hello everyone, in this video we are going to discuss about 2020 GATE question on fillet weld. Okay, go through this question. This question is also from welded connection. Once I'll read out the question. A flange and web plates of doubly symmetric built up section are connected by continuous 10 mm. See here, the required informations are marking continuous 10 mm thick fillet welds as shown in the figure. It means, see, these two are the flange plates and these two are the web plates. Now these two web plates are connected to these two flange plates. Okay, these two flange plates are connected to these two web plates by using fillet weld. And if you look at the fillet weld, details of fillet weld is done on both sides of the web. It means for this web, on both sides fillet weld is there at top and bottom. In the same way, for this web also, on both sides fillet weld is there at top and bottom. It means if you consider a neutral axis, it means here basically the major axis or principal axis for bending is always XX and it is considered as a neutral axis. Okay, so this is a neutral axis here. Here I will represent. So above neutral axis total 4 welds are there and below neutral axis also 4 welds are there. It means on both sides 4 welds are used. Okay, on both sides 4 welds are used for 2 webs. See here. Here 2, here 2. So total 4. Here also the same scenario. Okay, that is what the 2 lines of the question. Next, moment of inertia about XX axis. So for this cross section, moment of inertia about XX axis is 7.73 into 10 to the power 6 mm power 4. Okay, this is also required information. Now the permissible shear stress in fillet weld is 100 Newton per mm square. This is also another information. Okay, another information required to solve this question. Now what is asking? What is asking? The maximum shear force in kilonewton. As I keep on saying all the time, units very important. So the maximum shear force in kilonewton that can be carried by the section is. Okay, this is the connection details. Okay, this is the diagram. Okay, this is the diagram and connection details are nothing but fillet on top and bottom. Total 4 welds are used. Okay, total 8 welds at top 4 and bottom 4 and size of the fillet weld is 10 mm. That is what mentioned. These are the connection details and this is the total cross section. This is the total cross section. Now he is asking us to find maximum shear force in kilonewton that can be carried by this section. And one important information is given, that is this one. The design shear strength of the section is governed by the capacity of the fillet weld. It means whatever the capacity or whatever the strength of the fillet weld is there in shear, the same strength valid or applies for this section also, this doubly symmetric section also. Is that clear? That is a very important point to be noted. It means whatever the shear strength is there for fillet weld, the same strength is existing for the cross section also. So based on this only we will move forward to solving this question. Okay, for solving this question. Is that clear? Now I am going to rub this diagram. I will not rub, but the question I will rub. An important information, so just I'll. This is the diagram. Okay, this is the diagram and these are the informations. So first let me list out those informations here given. So this is the size of the fillet weld. S is equal to 10 mm. If you know the size, then throat thickness can be calculated. That is 0.7 into S. This is the relation we have studied and of course this was mentioned in code also. How much it is? 0.7 into 10, which is 7 mm. Clear? Now other information related to the cross section, that is moment of inertia about this axis, XX axis, which is a neutral axis or principal axis, is 7.73 into 10 to the power 6 mm power 4. And permissible shear stress, let us consider it as QP or Q, simply Q. How much? 100 MPa. These are the given informations. Now he is asking us to find the maximum shear stress that the given section can carry. Okay, given section can carry. Now this particular question can be solved by having the knowledge of formula we have studied in strength of materials related to the shear stress in beams. Now, whatever the formula we have studied in strength of materials related to the shear stress in the beam, the very same formula here we are going to make use. That is the reason I keep on saying all the time. If you are clear or familiar with the concepts of strength of materials, then we can learn and understand these steel structures very easily. And obviously, by understanding and learning, we can score the maximum marks. That is what required here, right? So first, let me write the formula, which is known to you, but still it is well required. That is the reason again I am writing here. Shear stress in beams Q is equal to FA y bar by IP. And for using this formula, one should have the knowledge of not only this formula, but terms present in that formula also. Okay, one should have the knowledge of terms involved in that formula also to use this formula easily. Now let us see what are those terms. Here Q is nothing but shear stress. I am not writing it again. And F is nothing but force, okay, shear force, which is what we have to calculate here. Now coming to the AY bar. This is somewhat the tricky term here. Okay, this is somewhat the tricky term in this formula. Now AY bar is the first moment of area. Okay, first moment of area bounded by the point of interest. Bounded by the point of interest and extreme fiber of the section. It means at what point in the cross section shear stress is required. So that is the point. Okay, that is the point of interest. So from that point to the extreme fiber, whatever the area is there, so whatever the area is present between the point at which shear stress is required and extreme fiber of the cross section, now the moment is to be taken for that area about neutral axis. That is the meaning of AY bar. So what is AY bar? Once I will read. First moment of area bounded by the point of interest and extreme fiber of the section. Is that clear? That is what AY bar. And coming to the I, it is moment of inertia about major axis or principal axis or neutral axis. One and the same. For bending, x-axis is the major axis or neutral axis or principal axis. One and the same. Is that clear? So moment of inertia, I am not writing. Now B. Coming to the B, again this also is somewhat tricky dimension here or parameter in this, but not so confusing like AY bar, but still B. Coming to the B, for solid sections, okay, for uniform solid sections like rectangle, B is uniform throughout the depth of the cross section, yes or no? But for open sections like I section and for this type of sections, B is not constant throughout the depth of the cross section. Clear everyone? Now here we have to choose B wisely. Okay, we have to choose B perfectly, then only we will get the correct answer. Now how to choose the B? This is what the point here. And okay, how to choose the B and how to find AY bar? There where the question lies. Okay, there where answering this question lies. If you know these things, then we can answer the question very easily. Now what is the AY bar? As already we know. So it means which area is to be taken or which moment of area is to be taken, and what is the B? As I said, that is only the tricky part in solving this question. Now let us see what is AY bar and where to take B. For that we need to recollect one point what I have highlighted in the question. So what is that point? The design shear strength of section. Okay, design shear strength of the section is based on the design strength of the fillet weld. Yes or no? That is what the point clearly mentioned in the question. It means wherever the fillet weld is present, okay, wherever the fillet weld is present, at that location we need to take B. Okay, and at that location is only our point of interest, or at that location only shear stress is to be calculated. So from that location to the extreme fiber, we need to take the moment of area about neutral axis. Is that clear, everyone? So just because of that point, we need to consider this section for calculating AY bar. So this is our point of interest. Okay, this is our point of interest, or this is the location where shear stress is to be calculated, and this is extreme fiber. Okay, this is extreme fiber. Now moment should be taken for this one. So whatever I am shading here, the moment is to be taken for this shaded portion. Okay, for this shaded area about neutral axis. Clear now, everyone? Hence find out the its CG. So see here, total is 120. Yes or no? So total is 120. So it means half, as total is 120. then obviously half will be half in 120 is 60, right? From that, subtract this. It means half in 10 is 5. It means CG of this shaded portion from the top lies at 5 mm. So from the top, CG of the shade area lies at 5 mm. Then this is Y bar. Okay, this is Y bar, which is 55 mm. Very simple calculations I am doing on the board. So Y bar is the CG of the shaded portion from the neutral axis. So by multiplying this Y bar with area of the shaded portion, we will get AY bar. Clear everyone? Now AY bar is nothing but for this question area. So area is nothing but area of the shaded region is nothing but 100 into 10. Now Y bar is 55. So now 100 into 10 into 55. If you see the units mm cube, this is AY bar. And of course I is known to us. Now B, what is the B is to be taken? B is to be taken the total throat thickness of the fillet weld. It means that at this location and at the junction of these two webs and flange, 4 fillet welds are there. Now throat thickness of each and every fillet weld is how much? 7. Now total 4 fillet welds are there. Now here B is nothing but 4 into TT. That is 4 into 7, which is equal to 28. Now each and every term, and of course here Q and QP are one and the same. Now each and every term is known in this formula except F. Then we can calculate F. Okay, by substituting these values and simplifying, we'll get F. That is what the answer. So here I'll write. So from that formula, F is equal to Q into IB divided by AY bar. So now Q is how much? 100. I is how much? 7.73 into 10 to the power 6. And B is 28. Divided by AY bar is how much? 100 into 10 into 55. Clear? Upon simplifying, we'll get this force. Okay, we'll get this force. The force comes out to be 393.53 kilonewton. That is a force. That's it. So always keep one thing in mind for solving the steel questions. Okay, for solving the steel questions, don't be panicked just by seeing the question. First go through it. And try to recollect the concepts. It means if we can recollect the concepts, okay, we can recollect the concept if and only if we have studied it. Okay, if and only if we have studied it, right? So first study the steel structures. As I said in the introduction of our discussion itself, we can easily answer or we can easily gain the marks from steel structures if we go through it. Okay, if we go through it. See here, this is also one more easy question. Basically, this question can be solved by making use of concepts of strength of materials. It means this formula. That is the reason strength of materials is a basic subject for the steel structures. Is it clear? Take it down.